Okay, so in this question we're giving 3 points. A as -3, 2, B as -1, 7, C as 4, 5. What to do first in part A is to plot the points, which I did here. I have a -3, 2, -1, 7, 4, 5. So this is my sketch of my triangle in this question. Now part B asks me to determine if the triangle scalene, isosceles, or equilateral. Okay, so what I'm going to do to prove that, and a quick review here, that an equilateral triangle has 3 equal sides and all the angles equal about 60 degrees. An isosceles has 2 equal sides and also 2 equal angles right there. And a scalene has no equal sides and no equal angles. So, when I find the distance or the length of all these line segments, if I have 2 that are the same and 1 that's different, then that proves that I have an isosceles triangle. That also proves that these 2 angles, or whatever the 2 angles opposing from those sides, will also be the same. So when I find the line segment or the length of AB using my formula x2 minus x1 squared plus y2 minus y1 squared, I get root 29 for AB. And then for BC, I also get root 29. So we're pretty happy. We've already proved that 2 sides are the same. Let's make sure the last side, right here, the length is different, right? Because if it is the same, then you're stuck in that equilateral triangle land, right? So right here, you do all the math of x2 minus x1 squared plus y2 minus y1 squared, you get root 10. So good. You have 2 sides that are the same and 1 that's different. Therefore, you have an isosceles triangle. Now, the next part of the question is to prove that the triangle has a right angle. And how we're going to do about that is, based on my sketch here, it seems that the biggest likelihood of a right angle existing in this triangle based on my sketch is right here. Or we could say angle ABC, because ABC. So I'm just going to erase this part right here. What I'm going to do essentially is, if the slope of this line segment and this line segment, if they're negative reciprocals of each other, we know that it's going to be perpendicular. Now, let me just double check here. Erase that all. Awesome. So let's find the slope then between B and C. So the slope of BC is equal to y2 minus y1 over x2 minus x1. So what we get is 5 minus 7, 5 minus 7, and 4 minus minus 1. So I get minus 2 over 5 as the slope of BC. Let's find the slope of AB. So the slope of AB is equal to, let's see, 2 minus 7 over minus 3 minus 1 is 5. 2 minus 7 is 5 over 3 plus 1 is negative 2. So I made a little bit of a, let's see, is that a negative 3 minus 1, so plus 1, 5 minus 7. So this is not negative 2, 5. Where is it? 1 second here. Oh, my bad. What am I doing? Minus 1, minus 3. 7 minus 2 is there. And then minus 1. Yeah, perfect. Made a mistake there. So I have over here, we're good. We have minus 2 or 5. And then AB, 7 minus 2 over minus 1 minus 3. Okay, perfect. So you have 5 over 2. Okay, awesome. So what you have here is that when you find the slope of BC, you get negative 2 over 5. And over here, the slope of AB is positive 5 over 2. Because the slopes of the 2 line segments are negative reciprocals, that means they're meeting at a 90-degree angle and they are perpendicular to each other.